Guys, today we're gonna do a math tutorial about geometry. First of all, you gotta know geometry is all about shapes and other stuff. You learn geometry, it's required for building, it's for architects, those things. Okay, I'm not gonna yap anymore. I'm gonna get started for today. Okay, today I'm gonna start by learning the difference of line, ray, and the line segment. What is a line? What is a line? What is a line? A line is simple. You might think of lines like this, but no. Lines don't have both points. Lines don't have both points. Let's pretend the 2 points were not there. Lines don't have both points. What this means is that the line can stretch anywhere to the left and anywhere to the right. The line can stretch infinitely in both directions. That's a line. How about a ray? A ray, you can probably imagine a flashlight. A flashlight. Got a drawing, so just imagine there's a flashlight. It's a sharp flashlight. Then it can emit light, and then there's light beam going straight. It has one point, so it can't stretch no more to the left, but it can stretch to the right. So ray is basically just like a line, but you can only stretch to one direction, either left or right. You can change the line. You can change the line where is it facing. You can change it like here, here, here. It doesn't matter. But like line can stretch in both directions. Ray can stretch only in one direction. Line segment. Line segment is interesting. Line segment is neither of them. You can guess. Line segment it's just a piece. It's just one segment. A segment of a line. It cannot stretch in both directions. So if I make a line segment in this, and then I say this is like 4 kilometers, and then it's 4 kilometers. It can't stretch. Can't stretch to the left. It can't stretch to the right. Can't stretch in both directions. So a line segment always have a measure. Always have a precise measure, like the length, I should say, yeah, length. Alright, so again, line can stretch in both directions. Ray can only stretch in one direction. And line segment can only, well, not can only, but cannot stretch in both directions. Okay. This is the difference between line, ray, and line segment. Alright. If you understand this, then let's move on. Why do I delete that? We can have that. We can leave it on here. Looks nice. Look at my drawing. Look at my drawing. It's not too bad. It's not too bad. Alright. Okay. Line can stretch in both directions. Ray can only stretch in one direction. Line segment cannot stretch in both directions. Alright, now we're gonna get into some geometry, more geometry. We're gonna talk about angles. Angles is like where two rays connect each other and then they form a point. They meet in a point. And then they create a corner. This corner is called angle. I do not like writing. This is an angle. And you can have an angle like that. You can also have an angle like this. This is also an angle. You can also have an angle like this. This is also an angle. Yeah, it's just a very big angle. Imagine you bend a ruler. Imagine bend a ruler. Imagine it's a ruler. You bend it. It's so stretchable, so bendable. It went all the way here, 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 here. So how much you bend? It's this corner. Alright. After knowing what is an angle, you can just go over some basics. Alright. So we're gonna say what is an acute angle. Yeah, acute. A right angle and an obtuse angle. Alright. So acute angle is those angles that are smaller than 90 degrees. For example, this is an acute angle. This is the angle, and then this is smaller than 90 degrees, and 90 degrees is like this. Why do I label it in a square? I will explain it later. Why is it smaller than a right angle? Cause look, the right angle is this much bigger than the angle we have here. So we are absolutely smaller than the acute angle. I mean, right angle, which is 90 degrees. So acute. I don't want another text box. Acute is smaller than 90 degrees. Right angle, like I just said, is equal to 90 degrees. Obtuse angle, you can guess it's bigger than 90 degrees. Alright. So, after done all of this, I'm gonna tell you why I labeled that right angle here using a square-like thing. So, imagine we have a right angle here. It is 90 degrees. Looks like 40. 90 degrees. So you can use like those rounded label things, but you can also, if you wanna just relax, wanna chill out, you can just use a square. Cause look, imagine a square. A square has 4 corners. 1, 2, 3, 4. And each of those corners is always 90 degrees, which we'll talk about later. It's always 90 degrees. So we use it like for labeling for a right angle. Alright. That's the explaining why it's such important for it to become a square instead of anything else like a rounded arc or something. Okay, that's our second part. That's our second part. Alright, now we are really going to be into some shapes. Shapes. What is a shape? A shape is some line, or more accurately line segment, that connect to each other. Like the points connect to each other. You cannot have a shape that is like this. This is not called a shape. You cannot also have a shape like this. This is also not called shape, because the two dots were not connected. The points were not connected. You have to connect the points. You have to connect the points and connect the points. Then it is really then it's really a shape, a closed shape. Alright, that's what I thought. That's a closed shape. Okay. Now we're gonna look at our basic shape, which is a triangle. Alright. Imagine a triangle, any triangle. Let's say we have this triangle here. And then we have this triangle here. This is called a vertex. Oh my god, I have bad handwriting. It's a vertex. You're not gonna read my handwriting if I write it like this. Each point, let's say on the line, like this, the arrows pointing at, is called a vertex. Alright, this is a vertex. And then this might be really funny name. What is the lines that's forming the shape called? It's called an arm in a triangle. Yeah, an arm. What would they call it? Look at this. Imagine someone standing here, and then they have two long arms. That's why they're called arms, I think. Alright. So, now what are we gonna do? It's actually gonna erase this. Erase this. Get out. Get out. Okay. So, we're gonna also have, you can also classify the triangles. Like, we cannot just say, yeah, this is a triangle. This is also a triangle. They're the same. They're not the same. Okay, they're not the same. You can classify them by something. What is that? What we just said. Yeah, angles. One way to classify them, you can use angles. For example, don't you think it's weird when we call something like acute triangle or right triangle or obtuse triangle? For example, we have an acute triangle here. Why? Because for each of the triangle, this angle is less than 90, which is acute. This is also less than 90, acute. This is also an acute angle. I cannot accept this to be happening. Those are also acute angles. So they're all acute angles. A triangle containing 3 acute angles, meaning it's an acute triangle. This is an acute triangle. an acute triangle. Alright. This is an acute triangle. Then what do we have? We have right triangle. But think of it. You cannot just make all the corners 90 degrees. Because if you make it 90 degrees, it's not gonna form a triangle. It's just gonna... You're not gonna use 3 sides. You're gonna use 4 sides. Then it's gonna form a triangle or a square. So, triangles cannot have 3 right angles, which we'll be explaining why later. It cannot have 3 right angles. So what do we have? Can we have 2 right angles? We just tested. No. Can we have 1? Wait a minute. We can have 1. We can have 1. Try to make it just very brief. This is a right triangle here. So we have 1 right triangle and 2 acute angle, obviously. That forms a right angle. Right triangle. That's a right triangle. Alright. If that's a right triangle, you guessed it. What is an obtuse triangle? Obtuse triangle might look weird. Yeah, that's a very exact array. Obtuse triangle. Obtuse triangle contain 1 obtuse angle and 2 acute angles. 2 acute angles. So this is the obtuse, and this is those 2 are the acute. So this forms the obtuse triangle. Alright. That's the obtuse triangle. Just don't like how the hands are posted. Alright. That's how we store. That's one way we can store 3 triangles. Alright. Now we're gonna talk about sides. We were sorting the triangles mainly by angles. What if we sort the triangles by sides? Imagine this, I have a random triangle here. Oh no, this one's actually not random. We have a random triangle here. Yeah, it looks chaotic. Nobody wants a triangle like that. It's called a scalene triangle. I don't even know if I pronounced that correctly. Scalene triangle. Why? Because look at the sides. No sides were equal. No sides were equal. No sides were equal. That's why it's called a scalene. It's most of the triangles. It does not have any same sides or same thing. Does not have any same sides. Now, what if we have a triangle that do have 2 same sides? For example, this one. Let's say this side is equal to this side. Yeah, there's I don't know. You can just make an angle like this. That's being mean. Oh my god. Yeah. So, what if we have a triangle like this? And then we can just go, look, those 2 are the same. This and this, those 2 sides are the same. So what is that called? That is called an isosceles triangle. Isosceles triangle. Oh my god. Isosceles triangle. Isosceles. Let Google do it. Google, bro. Google. Stop being deaf.
Isosceles.
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 Isosceles. Okay, I was pronounced it wrong 5 times in a row. Okay, that was embarrassing. Isosceles triangles has 2 equal sides. Okay, now we're gonna tell a fun fact about isosceles triangles, which Mr. Google had read for me. This angle, which is the one of the side that is equal, this angle, which is another side, the opposite side that is equaled, those 2 angles are the same. Those two angles are the same. This is the special part of isosceles triangles. You know, I want to pronounce that wrong again. This is the special part. That's just how special isosceles it is. That's why most people want it during their test. Okay, that was most people want it. Here's what all people wanted. What if we have a super duper friendly triangle that has 3 equal sides? That would be super helpful though. That would be super helpful. I would honestly think every single triangle should be like this. So friendly that there's 3. No, we're not talking about angles right now. The 3 sides are the same. 3 sides are the same, making the 3 angles are equal in 2. So what is this called? This is called an equilateral. Equilateral. I think I read this one. Equilateral. Okay, look at root word. It's like, isn't it similar to equal? Equilateral. Equal. So it's basically like 3 sides are always equal. 3 angles are always equal too. This is equilateral triangles. They're special. They're unique. They're very special. Okay. That's how we sort triangles. Let's do a little quick review here. We sort them by side. Angles. It can be acute triangle, right triangles, obtuse triangles. We can also sort them by sides. If all 3 sides are the same, they're called equilateral. Equilateral triangles. More accurately, isosceles triangles and scalene triangles. Again, isosceles means only 2 sides are the same. Scalene means no sides are the same. Alright. That's what we had. Next, we're going to try to calculate the area and the perimeter of a triangle. Well, I gotta tell you guys what is an area and what is a perimeter first. Area, perimeter. Okay, imagine a garden. I don't even know what are you guys playing. Grow garden, those things, steal a brain rot. I don't know. Imagine a garden with 3 sides. All of them were fences. this is fence, fence, fence. The inside is where the grass spawns, the flower grows, the trees, and then the fence, the length of the fences were called perimeter. So perimeter is the length of the fences. The area you can guess, it's the part in the middle where grass grows. Like this part. This part. Alright. If we're done doing this, it's time to do calculations. First, we have to calculate the perimeter of a triangle. For friendly questions, and for starter questions, they're gonna tell you all three sides. All you have to do to calculate the perimeter, you just simply need to add these three sides together. For example, this is 1 centimeter. This is 4 centimeter. This is 3 centimeter. Have like this, and then we're gonna calculate the perimeter. Perimeter, we use P instead to represent. Perimeter is all three sides added together. We can call this side A, B, and C. Perimeter is A plus B plus C, which equals to 1 plus 3 plus 4. The A and B and C can be different sides, so just call them whatever you want. We mostly use what A and B and C though. Equals 8. So the perimeter of this triangle is 8 centimeter. Don't forget to add the unit, else you're cooked on test. Okay. This is the perimeter. How about the area? For the area, you might get a little confused. How do I calculate the area of a shape that's built like this? Well, I'm gonna introduce you a new thing called a height. The height of a triangle. The height of a triangle. Just give me the angle already. Yeah, it's the height of a triangle. What is the height of something? This is the height of the triangle. Why? This part is 90 degrees. Always. This part is 90 degrees. Always. They're both 90 degrees. This is called the height of the triangle. It's like how tall you are. This is like how tall the triangle is. A triangle can have different heights. You might get confused when I say this. How can triangle has different heights? Humans can have different heights. Humans just tall. Nothing else. So for the height, you have the height on this side. You can have the height on this side, which I just drew. You can have the dot landing on this side. You can also have the dot starting from here and land on here. For example, like this. Yeah, that's a height. So, I'm gonna tell you some ways to model the height. It's so awful. Okay. For what's that called? Acute angles. You can just simply do this. 90 degrees here, 90 degrees here. Do this, 90 degrees, 90 degrees. Do this, 9 degrees, 9 degrees. Alright, that's the 3 heights of a triangle. Okay, that's 3 heights of a acute triangle. That's the easy one. Then I'm gonna do a right triangle. Right triangle has always been friendly, but not now though. A right triangle, if you do not understand, a right triangle can be really tricky. A right triangle has 90 degrees, which is you use the square to mark 90 degrees. And how we model the height of something? For this side, we can just simply do this, 90 degrees, 90 degrees. If we need to model this side, it's a bit trickier because we already have a line occupied here. We already have a line occupied here. So basically this line is going to be the height because it's 90 degrees. Oh my god. Oh my god. It's 90 degrees standing on here. It's 90 degrees standing on here. Look, it's 90 degrees. It literally satisfies what we just said. The height is 90 degrees, 90 degrees. For this side, it's also the same. We have like this as the height of this side. Okay, that's like the second tricky one. Its heights are hidden in the sides. Now we're going to real tricky. What about an obtuse angle? Well, for one height it's easy. You can just go this, and then right, right. What about this? We need on like this side. You can just do this. This will not equal 9 degrees. Obviously, this is not 90 degrees. This is not going to satisfy what he said. So, did I fail? No, I did not fail. Remember how he never fails. Oh my god. Well, we're gonna make this longer. What I mean by make it longer, we're gonna draw dashed lines to pretend it was here. Because, yeah, it does. Because the line, if we make it longer, it's gonna be here. Then we can finally get the point. Drag it down all the way to here. And then right angle, right angle. This is actually special because it's a unique way how you draw an angle. It's actually very unique. For this side, it's like the same technique we just used. We need some sort of longer lines. Then we can finally connect it. Here, 90 degrees, 90 degrees. Got it? Well, that was difficult, I know. That was difficult. You gotta take your time thinking about it. Take your time. Think about it. Don't rush. Not just gonna get mad at you if you just not get it. If you not understand anything, just comment. I will solve everything. I will solve everything for you. More accurately, Google's gonna solve everything. Well, I will be lazy. If I'm feeling super lazy, I just go on Google. Go ask Google, how do you calculate the area of something? It's gonna be like, it depends on what shape. Alright, don't fly off. Let's calculate the area of this triangle here. So we're gonna make the height of one side. Okay, we have the height here. We have the height here. Oh no, it's crashed. Oh, we have the height here. You have the height here. Yeah, obviously you have the height here. So height as always 90 degrees, like I said before. Alright. After we're done the height, most questions tells you the bottom part, or the part where you're landing your foot on the line. It's gonna tell you this. It's gonna tell you the length of this. For example, 4 centimeter, and then actually, don't blame me, 6 centimeter. Actually, this is 6 centimeter. This is 7 centimeter. No. I know what you're thinking about, okay? Chill. Hold on to that, okay? So, 6 centimeters, 7 centimeters, okay. We're gonna calculate the area. The formula of calculating a triangle is length times height divided by 2. You might not even understand why you gotta divide by 2. Why do you need to? Why do you need to do everything? Why do you need to multiply the heights? How? I don't understand. Help! Yeah, I know. It's hard. It's hard. It's length times height times height times height. Looks like I'm swearing something. And then divided by 2. I need equations, bro. Length times height. Length times height. You're gonna see in an equation. Oh my god! In an equation, you're gonna see the dot actually means the dot actually means multiplying in equations and algebra. The formula for triangles thing is called we use S for area, and then we have, let's say, triangle. Okay, right now you might be already thinking of how triangle sucks. I don't want to do it anymore. The area of a triangle is determined as being calculated using this following formula. Okay, so here we're gonna practice. We're gonna do that and then say equals to 6 times 7. You have to use the real X sign though. I can't type the real X sign, so it's my fault. Equals 6 times 7 divided by 2. Remember, when you are moving fractions, you have to always put brackets. And then equals 42 divided by 2 equals 21. And the area, the unit for area is called square centimeters. Square centimeters. I don't even know how I did that. It's always called square centimeters. Yeah, you can add the bracket or you can just don't add the bracket, I don't care. 21 square centimeter. Now I am gonna tell you why. By moving on to rectangle, you might be like, how? I don't even understand. I don't even understand the formula of calculating an area of a triangle. Why are you moving on? Well, chill, okay? I know the 6, 7 make you excited, but chill, okay? Hold on to that. You will soon find out that rectangles are really just the brother of triangle. Okay, here. Oh my god, the zoom is always garbage. Zoom has always been garbage since the start of this video. Okay, imagine we have a triangle. We have such a triangle that we have a right triangle. And then guess what? If we flip the triangle, we put two of them together. What's gonna happen? It's a rectangle. Look at it, it's a rectangle. Do you agree? Don't you agree? It's a rectangle. It's a rectangle containing 4 equal right angles. Okay, it's a rectangle. How do we calculate the perimeter? Perimeter is always like add the 4 sides together, but in this case, the two sides here are equivalent. The two sides here are equivalent. So if it only gives you here like 2 centimeter, and this and then this gives you 4 centimeter, don't panic. Just say, just do 2 times 2 plus 4. It's gonna be the same to repeating this side twice, which forms also the same as this side. Okay. Okay. So this is the rectangle, the formula for rectangle. Perimeter. Rectangle's perimeter. Rectangle's perimeter always been 2 times 2 plus 4 equals, it's like 2 times A plus B, just the 2 sides. In the speed run here, we don't have much time. For the area, I'm actually going to connect the 2 dots back. You can see it's like, if we divide them into rows and colors of squares, it's going to become a grid full of squares. So if we actually cut it, we'll get a bunch of squares, and then we can just do multiplication. So the area would actually be 2 times 4. It's that simple. It's just that simple. So if we're back here again, there, now you can actually explain why is it divided by 2. Length times height is basically just like this side and this side, they're multiplied. It's the sum of a rectangle, and then we imagine it was put in together, so we gotta divide it by half. Alright, so this is all for today. Thanks for watching. If you have any questions, put it in the comments, subscribe, and bye.